We are going to talk about ellipses both today and tomorrow. Tuesday, we will have a quiz over parabola and ellipses. Okay, so here's an ellipse. You are going to think of it as a switch circle, an oval, however you want to think of it, but this is an ellipse. Okay? An ellipse is actually how most planets orbit. Yes.
Ours is a perfect circle.
Okay. So here's our geometric property. An ellipse is a set of points in a plane where the sum of whose distances from two distinct points is constant. Why, thank you. Okay. What do I mean by the sum of the distances from our distinct points, our foci? We have one focus, two foci. That's plural. I promise.
It's like cactus and cactus.
Okay. So this distance right here is always going to be the same in your ellipse no matter what point you're talking about. Let me give you a demonstration. Okay, here's an ellipse. What I want you to notice, okay, so here are my two foci, and I have the distance to a point from each focus. I'm going to add them together right here. As I move along my focus, what do you notice? It is always the same. New ellipse. Still always 1029. Okay? So that is what makes an ellipse special. Okay? We have these two foci inside of our ellipse to where the distance from each, when you add them up from a point, is going to be the same throughout the entire ellipse. Okay? Now, let's learn about some more vocabulary. All right? Notice how one we're flatter on one side, we're not one side, I don't want to say it. Okay, we're shorter on one axis than the other. We're longer on one axis than the other. Okay? The longer portion of our ellipse, we call that the major axis, and that's where our foci lie. Okay? He's major because he's the biggest. Okay? The shorter portion is called the minor axis. Okay? Both of these are passing through what we call the center of our ellipse. Okay? And the major and minor axes are perpendicular to each other. What does this look like? A circle. A circle is a special ellipse, and we will talk about how to determine when you actually have a circle. No. What's going to be true about the major and minor axes? be the same as opposed to one's longer than the other. Okay? What? Okay. So let's talk about a horizontal one first. Okay, so we're going to talk about standard form of an ellipse. We're going to talk about our horizontal one first. It is horizontal if our major axis is horizontal. Okay, so it's longer horizontally. Okay, so here we go. A minus h squared over a squared plus y minus k squared over b squared equals 1. It must equal 1. Okay? Now notice how, first of all, x and y are on the same side. Second of all, x and y are both being squared. And what sign is in between our square binomials? Addition. Yes. No. I will tell you what C is in a little bit. C is a little more complicated. Alright? So, in order to be an ellipse, A has to be bigger, okay, than B. If A and B are equal, we have a circle. Alright? So you'll notice that the bigger number is associated with X. X we think horizontal. That is how we know. Whatever the bigger number is with, that tells us what our major axis is. Okay? So our center, just like our vertex for our parabola, is at HK. Alright? Our foci, alright, here's what I want you to remember about the foci. They are going to be C away from the center. Okay? And we know that our foci have to lie along the major axis. Okay? So don't really get hung up on this right here. Just remember that they're going to be C units away. And I'll tell you what C is here in a little bit. Okay? What I'm going to write here is that our major vertices are going to be A away from the center. And I'm going to call these right here our minor vertices. I'm going to have you give me both, because you're going to need all four of those to plot our ellipse. But I want you to tell me which ones are the major vertices, those are the important ones. Which ones are the minor vertices that give us our actual shape. Yes? Sorry, minor are going to be B away. Okay? A tells you how far for your major axis. B tells you your minor axis. Really? Okay? Whatever number is underneath the x, the square root of that, that's how far you move horizontally. Whatever number is your denominator under your y, that's how far you move vertically. X we think horizontal, y we think vertical. Okay? So let's compare this with the vertical standard form. Okay? Now you notice everything's the same except what? A squared and B squared are switched because A is always bigger And so when our major axis is vertical, the bigger number is with the y squared. So our foci are still, well, our center is still at HK, all right? Our foci are still COA, but since we're vertical, they're going to be along that vertical major axis. Our major vertices are still AOA, and our minor vertices are still BOA. Ellipses should be one of the easier conics to graph. The hardest part about this is the foci, and it's really not that hard. So you just have to remember a formula, which I will give you. X will always be vertical, but since b squared is associated with x, it's just going to be shorter. Okay? Whatever number is associated with x, that's how far you move horizontally. Whatever number is associated with y, that's how far you move vertically. If you want to determine later which one's longer, so the major axis versus minor axis, that's fine. Yes.
So how do you make sure it's equal to 1?
Well, if you have like x minus h squared plus y minus k squared equals 5, you divide by 5. Like if the number on the right side is not 1, you divide by that number. Well, it has to equal 1 so we can identify A and B.
Then wouldn't that just make A equal to 5?
Well, whatever I just said would be a circle. Okay. When we get into an example, it'll make more sense. But if you've completed the square, you have your x minus h squared, you have your y minus k squared. If it's not equal to 1, you divide both sides by that number to make it equal 1. Does that make sense for now? Okay. Let's talk about C. C squared is a squared minus b squared. Let's talk about that. Here I have an ellipse. Here's my center. Here are my foci. Okay? What is this distance right here? What is this distance right here? B. So what is this distance right here?
A triangle.
It's a right triangle.
It's a right triangle.
Square root of
B squared plus
okay, b squared plus c squared. Okay? What's this distance?
Same.
The same thing, right? Now we know that the sum of those two distances always add up to the same thing. Okay? So if I add the square root of c squared plus b squared plus the square root of c squared plus b squared, we have 2 of them, right? Alright, now this always equals the same thing. Do you know why? Okay. I want to go back to my picture. A minute. Okay. adding the red and the blue. When I get to my major axis, I have a red line. I have a red line that stretches from foci all the way to the vertex, correct? So how far is that? How far is it from here to here? How far is it from here to here? How far? A. Okay, so let's write this. We have C plus A, right? Now we have our blue line that stretches when we're here, but so we can see it, from focus to vertex. What's that distance? That distance is A minus C. Which is 2A. 2's go away, I square both sides. And there's our C squared equals A squared minus B squared. You don't have to remember that if that doesn't make sense to you. You can just accept it, but that's where it comes from. Okay? Our major axis has length 2A. That makes sense, right? Our minor axis has length 2B. Center to minor vertex, center to minor vertex. That's double B. Okay? If A equals B, then we have a circle. Everyone okay with what that is? Eccentricity. We find eccentricity by C over A. Okay? Our eccentricity will always be from 0 to 1, and it measures the ovalness of our ellipse.
So the closer to 1 is more circle.
What do you think? Closer to 1, it's more circle? Closer to 0. Closer to 0.
Oh, okay.
Okay? So the bigger the eccentricity, the more oval it is. Well, because what would A squared minus B squared be if A and B are the same? So yeah. Okay. Are you ready? Let's get to some examples here. Ooh, not in standard form, is it?
I think he did that on purpose.
Now, right away, how do I know it's an ellipse? X squared and Y squared, and they're both on the same side, but they're both positive. Okay? Since they have different coefficients, I know it's going to be an ellipse. If they had the same coefficients, we'd be working with a circle. All right? So, let's get this into standard form. All right? So, what are we going to have to do with each x squared and y squared? We want a binomial squared, so we're going to have to complete the square. So what I'm going to do, I'm going to group x squared and 6x together. And I'm going to group, can that 4 be in front of my y squared?
But 8y super.
We want x and y on the same side and the constant on the other side. Yeah. Oh, I see what you're saying. You want the 9 to be here because it will complete the square?
Yeah.
You want to keep it there?
Yeah.
Okay, so we can keep the 9 right there. That's fine. Now, I have to factor out this 4 from the y squared, which means we're subtracting 2y. And it equals 0 because I moved that 9 over here. Okay? So what completes my square? But what number am I really adding to the left side? Oh. This one is being multiplied to 4, so I really am adding 4. So to balance out my equation, I need to add 4 to the other side. Remember that? Okay. So what do we have? We have x plus 3, the quantity squared, plus 4 times y minus 1, the quantity squared, equals 4. Now remember, this must equal 1, so we have to divide both sides by 4. So x plus 3, the quantity squared, over 4, plus y minus 1 squared over 1 equals 1. Obviously, you don't have to put the over 1. I'm putting it to emphasize an a squared and b squared. Okay. So where do we have the bigger number, with the x or the y? With the x. So this ellipse is a horizontal because the bigger number is with the x. X we associate horizontal. Right? Okay. So first of all, where is our center?
Negative 3, 1.
Negative 3, 1. Very good. Okay. You are telling me that a squared is what? A squared is 4, which makes a, okay, a is 2. So we're going to go horizontally 2 and 2. So our major vertices are at negative 1, 1 and negative 5, 1. Because that's where I plotted my point. Well, since A is 2, I moved 2 units horizontally from my center. Because the 4 was with the x. X means horizontal. Now the 1 squared, or b squared equals 1, that's with my y. What is b? 1. So vertically, because we're with the y, we're going to go up 1 and down 1. So our minor vertices, because this is where we're shorter, are at negative 3, 2 and negative 3, 0. Not yet. What else do we need? We need foci. Now, how do we find c squared? A squared minus b squared. So c squared is 4 minus 1, which is 3. So c is the square root of 3. Now, approximately, what is the square root of 3? Let me do it in the calculator. 1 point. It's going to be closer to 4 than it is to 2. Or sorry, 2 than 1. 1.7?
Yeah.
So we'll plot them about right here. So we're going to say that our foci, we moved horizontally. So from negative 3, we subtracted radical 3, and we're still at y equals 1. And from negative 3, we added radical 3, and y is still at 1. What? Nope. This is it. Minus the eccentricity, which is
Hey, why didn't you press it earlier? Are we gonna have to remember that?
I may ask you. It's the least important out of everything. Okay. But you need to know how to find it. Okay? Questions? Yes. A squared is the bigger number down here. B squared is the smaller number down here.
So A is the square root of
It doesn't matter. Where it's at tells you if you're moving horizontally or vertically. But the bigger number is always A squared. Okay. Let's try another one. Alright, so is this an ellipse? Yes, x squared and y squared are both present, they're both positive. Okay. Well, we're going to have to put it into standard form. So here we go. First of all, x squared has a coefficient of 9, so that needs to be factored out of x squared, which means it also needs to be factored out of 36x. We have a coefficient of 4 in front of our y squared, so that needs to be factored out. It also needs to be factored out of negative 8y. And this equals negative 4 plus our two mystery numbers. Okay. Now, what completes our square here? 4, but it is really being multiplied to 9, so to balance we need 36. Not in here because it's really 36. Yeah. Okay. What completes the square here? 1, which is really 4, so what we have is 9 times x plus 2, the quantity squared, plus 4 times y minus 1, the quantity squared, equals 36. What? What are we supposed to divide by? We have to divide by 36. What's 9 divided by 36? 1/4. What's 4 divided by 36? 1/9. There's our standard form. So is this a horizontal or vertical ellipse? Vertical, because the bigger value is underneath our y squared. Alright, let's identify everything. The center is where? Okay. Our major vertices, are they going to be horizontal or vertical? They're going to be vertical. A squared is 9, which means A is 3, so we're going to move vertically 3 units. And I'm going to write those coordinates down for our major vertices. So let's see.
-2 and 4, -2 and 4.
Now, our minor vertices. Okay, what is b squared? 4, so b is 2. So I'm going to move 2 units horizontally since the 4 is associated with the x. X we associate with horizontal. Those coordinates are 0, 1, and -4, 1. Alright, so here's our ellipse. And green. We need our foci. C squared is, what is a squared minus b squared? So c is the square root of 5. Approximately how far is the square root of 5? Remember, they need to go along the major axis. So our foci, we moved vertically, so we're still at x is -2, but from our center of y is 1, we added the square root of 5, and from our y, we subtracted the square root of 5. Now, I will allow you to write it as this. If it's a non-integer, you can write it as one coordinate with a plus or minus. If you write 1 plus or minus 3, I am going to dock you points, but you can do that. If c is a nice value, like an integer value, or a fraction, you can do that computation. Okay? If it's irrational, you can just write it like that. What's the eccentricity? Do you agree? Any questions? If we have a circle, we're going to find a radius. Okay? Now, how do you know it's a circle? The coefficients of the x squared and the y squared are the same, therefore it is a circle. X squared plus y squared equals. Now when it's a circle, it doesn't need to equal 1. You can leave it like this so you can identify what the radius is. Where's our center? What's our radius? Okay. Now if I did write it like an ellipse, x squared over 9 plus y squared over 9, you notice how a and b are both 3, hence the radius of 3. A squared minus b squared is 0. So c is 0, which means our eccentricity is 0. The closer it is to 0, the more circular it's going to be. Yep, the more oval, the closer it is to 1. Well, to be an ellipse, it needs to be between 0 and 1. How's that? Okay. You can what? There is your homework. Not too many problems.